Okay, here's another challenging partial fraction decomposition. Okay, so let's do this first. All right, so I know it's going to be, this is a linear factor, so it's a over x minus 3. This is a linear factor also, but I have to build up to that squared power. So I'll have a b over x minus 2 and then a c over an x minus 2 squared. So be careful with that. All right, so now I'm going to multiply through by this denominator, and this is where so many mistakes are made, but not by you. Got confidence. You won't do this. Okay, so I'm going to multiply by x minus 3. I'm just going to squeeze it in here by x minus 2 squared. X minus 3, x minus 2 squared. So these cancel. So on this left-hand side, I'm left with x squared plus 1. Always turns out to be just the numerator. Be careful multiplying. This times this here, the x minus 3 cancel, so I get a times x minus 2 squared plus. Okay, now I'm going to multiply this times this term. One of the x minus 2's cancel, so I'm left with b, x minus 3, x minus 2. All right, and then let's go to the last term. When I multiply this times this, I get a c times an x minus a 3. Whoop, x minus a 3. All right, now I'm ready to plug in some wise numbers. So look at it. I think let's let x equal 2. So if x is 2, that's gone and that's gone, right? So putting 2 on this left-hand side, I get 5 equals, put in 2, I get a negative 1. So then c is a negative 5. Got one number. All right, now 2 others to go. Is there another good number to plug in? There is. So let's let x equal 3. So when x is equal to 3, I get 9 plus 1 is 10 equals, so these both are 0. And put in x equals 3, I get 3 minus 2 is 1. So look at that. 10 is equal to a. Now, there are no more good numbers to plug in. That's all we have. So be careful. So I'm going to suggest we think about multiplying it out. Maybe we don't need to multiply it all out. We're looking for b, right? I see b is in front of an x squared term. So if I'm looking at x squared terms, on the right-hand side, there's no x squared there, so I get b. Oh, there'd be an x squared here, so I get a, and on the x squared on the left-hand side, it's 1. Oh, wait, I know what a is. A is 10, so I get b is negative 9. Okay, so now I need to go plug all of those things in to the original setup that I had, right? So try to erase enough stuff so we can plug all the information in. So important to stay neat and organized, right? Okay. Don't need that. Okay. There we go. Okay. So this is going to be integral. What's that? The negative. It's an equal 10 over x minus 3 minus a 9 over x minus 2, and then minus a 5 over x minus 2 squared dx. All right, so now you're going to be careful in taking the antiderivative. The first two terms are just easy u substitution, which resulted in ln, right? So this will be 10 ln of x minus 3 minus 9 ln of x minus 2. And then this one here, you need a u substitution for. So I'm just going to go slow, taking steps, making sure I don't make a mistake. So u equal x minus 2 du is dx. So then this turns into minus 5 u to the negative 2. Oh, right. If I add 1 to the exponent and put it over that number, so this will give me a positive 5, 1 over u. Okay, so I'm going to put that in there. So I get a positive 5. Carry everything else along. ln of x minus 3 minus 9 ln of x minus 2. plus a 5, 1 over x minus 2 plus a c. All right, let's do this one. So you see the partial fractions, doesn't need long division because the degree of the numerator is smaller than the degree of the denominator. So x squared minus 2x minus 1, x minus 1, x squared plus 4, a over x minus 1 plus bx plus a c over x squared plus 4. All right, so again, we're multiplying through by this denominator, right? Multiplying through by that denominator, x squared plus 4. Okay, so on this left-hand side, I get x squared minus 2x minus 1. And then I get a x squared plus 4 plus bx plus c, parentheses necessary, right? Be really careful about that. So is there a good number? There is. Let's let x equal 1. X equal 1, that term goes away. So if I put in 1, 1 minus 1, so I get a negative 2 is equal to a 5a. So a is equal to negative 2/5. Oh, we just did this problem, didn't we? Oh, well, I'll just finish it up in case you didn't see the last video. So now I need to go find a good way to find out what b and c are equal to. So again, I'm going to take the time to rewrite and put that in. So x squared minus 2x minus 1, negative 2/5 x squared minus 2/5 times a 4. So this here multiplied out because it's really important to make sure you see all of the terms. So let me put it in a different color, plus. So it'd be bx squared minus bx plus a cx minus a c. Whoops, minus a c. Okay, so let me just write that again a little neater. So I get a negative 2/5 x squared minus a 8/5 plus a bx squared minus a bx plus a cx minus a c. So what am I trying to find? I already got the a, so I'm looking for b and c, right? So in order to find b, oh, look at that. B is in front of an x squared term. So in x squared terms, I've got b on the right-hand side and a negative 2/5. Those two things have to add to, go away, have to add to a 1, right? Because that's the coefficient of the x squared on the right-hand side. So b minus 2/5 has to equal 1. So that must be b is equal to 7/5. All right, got the a and the b. Now we're looking for c. So I can do different things. So let's see. I've got the c as a constant, and there's a constant. So I have a negative 8/5 minus a c is equal to negative 1. So if I don't know, I'll just kind of play around. I'll add c to both sides and then add 1. So that means c is equal to negative 3/5. And you could solve for that different ways, right? Okay, I've got the a, the b, and the c. So now I go plug them back in. Good thing I kept this, because this is going to help me to know where to plug everything back into, right? Right. Okay. Sorry. Takes a bit of time. Okay, so let's do it black. Maybe you can see it. So the A is, oh dear, did I erase my A? Oh no, I erased my A. Ah, shucks. So let me think about, hold on. Okay, found my A. So now I'm ready to do the integral. So the first one is just an easy ln, not a problem there, right? So I get a negative 2/5 ln of x minus 1. This one, I know I need to separate around that subtraction. So I'm going to do that. 7/5 x over x squared plus 1 dx. And then minus 3/5 1 over x squared plus 1 dx. Okay, so you can see that this second integral right here is easy u substitution, right? So I'm just going to carry this along, ln of x minus 1. You see it. U is x squared plus 1. du is 2x dx. So I'd get this plus a 7/5 and then a 1/2 ln of x squared plus 1. And then here, minus 3/5. You see it. It's arctangent of x plus a c.